Chapter 6, Lesson 3 of Advanced Algebra, and in this video we're going to redo these problems that we did using long division, and we're going to do them using synthetic division. So a few reminders when it comes to synthetic division, things that we have to remember to be true. First off, we need to make sure that the divisor is in the form x minus a. It doesn't have to be an x, but it has to have x, cannot have a coefficient with it, and it has to be linear. So we have to look for that first. We're then going to find the divisor 0, so what the 0 of the divisor, and we're going to use that to begin synthetic division. We'll need to make sure that our dividend polynomial is in standard form, and then we'll list the coefficients, and then it's simply multiplying and add, and then we'll put the variables back in at the end. Remember that we're going to begin with the variable exponent that's one less than what the dividend exponent began with. All right, so kind of remembering all those things, let's go ahead and take a look at these problems. So in problem number 1 here, I notice that my divisor is in the proper form, x minus a. All right, and I need to know what makes this 0, and that's -1. So -1 is going to be what I'm going to divide by. My dividend polynomial is in standard form, so I'm going to simply list the coefficients in order. So I have a 5p cubed, 2p squared, -8p, and then a +1 as a constant. Now I'm going to draw my line, and I'm going to bring down the first number, first value, and now it's simply multiply and add. So -1 times 5 is -5, and then we add. And then we multiply, and then we add. And then we multiply, and then we add. So now that the division is done, we need to put the variables back in. Because the dividend began with a p cubed, my answer is going to begin with a p squared. These are the coefficients. I simply put the variables back in. So 5p squared minus 3p, these will go down in 1 as I move from left to right, minus 5, and I have a +6 as a remainder over p plus 1. So you can see I arrived at the answer synthetically, and that did take a little bit less time than it did doing long division. Okay, so you can see how synthetic division comes in handy. All right, so let's go ahead and do number 2. So again, we need to check this divisor is in the form x minus a, so I can use it. What makes this 0 would be the number 5, so that's going to be my divisor. My dividend polynomial is in standard form, so I go ahead and just list my coefficients using placeholders if needed. All right, so I have a 1m cubed, -3m squared, -9m, and then a +2. So I draw my line, I bring down the first number, and now I'm just going to multiply and add. So 5 times 1 is 5, minus 3 is 2. We're going to multiply and add. We're going to multiply and add. So now I simply put the variables back in. Because this was a cube to begin with, I'm going to begin with a squared. So this is 1m squared, and then a +2m, +1, with a remainder of a +7 over m minus 5, and there you have the answer again synthetically, which is quite a bit quicker than using long division. All right, let's do a few more of these easy ones, and we'll take a look at those more difficult ones and see if we can't tackle those using synthetic division. All right, for number 3 here, I'm looking at my divisor. It is in the form x minus a. This is a coefficient of 1, so I can use synthetic division. So I'm going to use the 0 of this value, so that's going to be -5. It's going to make that 0. And then my dividend polynomial is in standard form, so I just list the coefficients. So I have a 1n cubed, 8n squared, 13n, and a -6 as my constant. Draw my line, bring down the first number, and then multiply and add. So -5, and that's going to be 3. So -15, that's going to be -2. 10 and add is 4. So I have an x cubed, or an n cubed to begin with, so I'm going to begin with n squared. So this is 1n squared, and then they go down as we move from left to right with a remainder of a +4 over n plus 5. So I have my answer doing synthetic division. All right, let's do one more of these kind of easy ones, and we'll take a look at those more difficult ones. Number 4 here, my divisor is in the form x minus a, meaning the coefficient of 1, so I can use synthetic division. Negative 8 will be my 0, so I will use negative 8. My dividend polynomial is in standard form, so I can list the coefficients. There's an x cubed, x squared, and x, and then a constant. We'll bring down the first number, and now it's multiply and add. So negative 24 and 20, that's 2. Negative 16, so that's negative 6. That's a positive 48, negative 3. So I'll begin with an x cubed, so this is going to begin with x squared, so that's a 3x squared, a 2x, and then a minus 6 with a negative 3 as my remainder. So this would be my answer using long division. Okay, those are kind of easy. Let's take a look at those more difficult ones and see if we can use synthetic division with those. Okay, as I look at number 6, as I look at my divisor, this is not in the form x minus a. This first value has a coefficient other than 1, so I cannot use synthetic division for this problem, so there's nothing more I can do. I have to use long division for something like that. So again, make sure that we check and make sure this is in the form that's usable. Otherwise, we cannot use synthetic division. If we tried, we'd get an answer that would not be what we have there. As I look at number 7, this also is not in the form that I need, x minus a, so I cannot use synthetic division for number 7. Going over to number 8, now this is in the form that of x minus a, so I can use synthetic division for this one. So this is in that form, so what makes that 0 is a negative 3, so I'm going to use negative 3. My polynomial, my dividend polynomial, is in standard form, so I can use it, but I notice that there are some missing exponents here, so I need to remember to use placeholders. So I have an r1 to the 5th, to the 4th, 9r cubed. I don't have an x squared, I don't have an x, and then I have my constant. Very important that we remember to use those placeholders, otherwise we're going to get an answer that's not the correct one. But now that I have that, everything else is the same, so multiply and divide. Or multiply and add, excuse me. Negative 6, so this is going to be 3. Negative 3 times 3 is negative 9. So that's 0. Negative 3 times 0 is 0, and add. 0 and add, and 0 and add. So again, because I began with a 5th here, I'm going to begin with r to the 4th. So this is 1 r to the 4th plus 3r cubed, 0x squared, 0x, my constant is 0, so this is my remainder. So I have a remainder of negative 8, then over r plus 3, which is my answer. So you can see synthetic division works as long as I remember to use these placeholders. If I forgot these placeholders, then I'm going to get an answer that's not going to be correct. All right, so make sure you check for that. All right, let's see if we can use synthetic division for any more of these last few that we have here. Number 9, I cannot use synthetic division because this is not in the proper form, x minus a, so I'd have to use long division for that one. And for number 10, I cannot use it here either because this is not in the form x minus a. So you can see synthetic division is very nice when it works. It takes a short amount of time, shorten things up quite a bit, but we do have to remember that it doesn't always work, so it's very important that we remember when we can use it, and then go ahead and use it, and it'll make your life a little bit easier when it comes to dividing these polynomials.